From MTN, the Montana Television Network, this is Face the State.
Good morning and welcome to this week's edition of Face the State. I'm Tim McGonigal. Today's program focuses on the Montana State Grain Lab in Great Falls. It's believed the Grain Lab has been in Great Falls since about 1918, and for good reason. It's centrally located, and Great Falls is where the grain is. Nearby are some of the state's major grain users. Across the tracks from the Grain Lab is Cereal Food Processors. About 3 blocks away is General Mills. It was about 5 years ago the state of Montana allocated $750,000 for renovations to the Grain Lab, which plays a bigger role in our lives than many of us think. From the flour used to bake the bread we eat, to the barley that goes into the beer we drink, even the mustard we slather on our hot dogs at baseball games and summer barbecues. There's a good chance the key ingredients that help make those foods were first tested at the Montana State Grain Lab.
Grain samples basically come to our lab 3 different ways. Many samples come to us by the producer. They will take what they call bin samples, and they'll physically drive to our lab and drop off their samples themselves. The other way that samples come to us is the elevators send samples here on the farmer's behalf. So as grain is being delivered to an elevator, those grain trucks are probed, those samples are collected, and then every morning the delivery service shuttles those samples from elevators and they arrive here. The third way that we get samples is where we physically go out and sample off of a rail car or out of a warehouse.
The Great Falls Lab is actually one of 2 in Montana. The other is in Plentywood. Montana grows 32 commodities, including spring wheat, winter wheat, 2-row malting barley, and more recently peas and lentils. You might be surprised to know that garbanzo beans are also grown in the Treasure State. So is mustard, which despite some more modern sampling equipment, is still tested in the old-fashioned way.
People ask about this old machine that sits back on the back counter, and they say, well, is that an antique? And so the non-sarcastic answer is yes, it is an antique, but we use it every day. We use this for processing mustard samples, and we literally process hundreds and hundreds of mustard samples every year. There is a group here right in Great Falls that is brokering mustard throughout Montana and up into Canada, and all those farmer samples come here and we analyze the quality of those mustard samples. This machine was actually bought in around 1946. We paid $157 for it. We have tried to replace this, and this company, they're actually still in business. But the machines they make nowadays are the size of a building.
As farmers harvest crops and offload them into a bin, they need to determine the quality of the samples. Producers, grain mills, and commodity brokers all need to know the quality of grain as it moves through the system.
So the sample comes into us. It's identified as to the farmer, where he's located, and what various tests that he wants. So the first step in the analysis is we would pour the sample that he submitted to us through our divider, so we get a nice random sample of what he's sent to us. And we need about a quart of grain in order to run all of our tests. So we'll go ahead and weigh that out, and we'll record those values on our ticket, and that would be the initial part of the examination.
One of the roles of the State Grain Lab is to protect the food supply. Rumney says most years the majority of wheat is excellent quality, but sometimes untimely rains and other factors can cause unforeseen damage. And for grain that sits in the bin, sometimes up to 10 years, the quality is always going down. The next step in the testing process is measuring moisture content.
The farmer gets paid for delivering grain, not water. In the Midwest, where a lot of corn and soybeans are grown, excess moisture is one of the biggest threats to the commodity. Here in Montana, where we're high and dry, most of our samples come in at a very acceptable moisture level. So I'm going to tell the machine that we're working on spring wheat. Simply pour the sample in and load the sample in the machine, and in a few seconds we'll get a moisture content. So that moisture content was 12.6. That would be a normal moisture content for Montana.
Rumney says all official grain labs have the same moisture analysis machines, meaning grain tested in Montana would have the exact same reading as in Kansas City or Seattle. The sample is next cleaned in what is known as a dockage machine, which acts like a combine.
So this is the sample as the farmer would deliver it. And you see it's mostly clean grain, but there's some portions that we have unthreshed kernels that need to be separated and weighed up. So this is the dockage machine, and it's going to clean the sample. So this is essentially like a little combine. There's a fan in it that will blow the light material out, and a series of sieves that will sieve out the weed seeds. What we call the riddle will bring out the unthreshed kernels, and all this will be weighed up as dockage. So now we can see the sample after it's been cleaned. We have the clean grain, and we have what is considered the dockage. And the farmer is not getting paid to deliver dockage, so that would be a discount for a producer. The next step in the process is test weight. And test weight is a very, very old measure of grain quality. The test weight device actually measures the plumpness of the grain. And it makes sense. The plumper the kernels, the more flour we can extract off the wheat. The plumper the kernels of barley, the more beer we can make. So it's a very quick and dirty method of measuring grain quality. So simply pour the grain in through the device, and the test weight kettle will overflow with grain. And there's a standardized procedure that we use for striking off the grain. And we weigh that up, and this scale is then calibrated to pounds per bushel. And you see this is weighing at 60.9, so that would be considered a good test weight. The producer would definitely be happy with that test weight.
Test weight can be affected by drought conditions. Next up in the process is called shrunken and broken, a process that separates big kernels from smaller ones, and it's different for each commodity. For wheat, it gets divided several times before making its way to be analyzed.
So there's the shrunken and broken portion of the sample. And you can see that that's still wheat, but it's really so small that it can't be used for making flour. You know, indeed, you could use it as chicken food, but it's not going to be used. It's not going to be useful in the mill.
Once the mechanical factors of wheat, such as moisture content, dockage, and test weight, have been analyzed, it then comes under the watchful eye of the inspector.
All of our inspectors are trained by us, but licensed by the federal government. It takes about a year's worth of study and training to become a wheat inspector. And it's not a trivial effort also. The federal government comes into our lab and analyzes the work that inspector does and grants them a license. And that test to get the license might take up to 5 days of analysis.
One of those grain lab inspectors is Lauren Allman.
What Jeff broke down in the back room will come out to us, and we will go through it. This would be what came through the dockage machine. And I will look through in here, and I will look to see if there's anything out of the ordinary that I need to look at. For example, insects, if there's any live insects in there. Dead insects, also an indication of might be damage in the sample. I will be looking for if there's rodent pellets, fertilizer pellets, anything out of the ordinary. Stones, if there's bigger stones in there, it'll give me an idea to keep an eye out for stones in the sample. If I don't see anything in there, I'll weigh that sample up. Do my math facts here, and that'll give me a percentage of dockage within my 1,000 gram portion, which is that represented portion of the rail car, the bin, the farmer sample, whatever they wanted to bring in. Then I look at my shrunken and broken. That is what the last step Jeff did at the sieve there. This is what was pulled out of a 250 gram portion. I also look in there for stones, see if there's any stones in there that looks like dirt clumps. Any rodent pellets in there I keep an eye out for. All right. And then my 1,000 gram portion, I'm gonna go through this sample for stones, rodent pellets, fertilizer pellets, anything that shouldn't be in a good quality wheat sample. First thing I'm gonna do is just kind of mix it up a little bit, and I'm gonna do an odor test. I'm gonna smell for musty, like a earthy odor, a sour odor, insect, and a COFO, which is a commercially objectionable odor, like skunk. You could also have fumigant, insecticide. That's stuff that we don't want to eat. And then I will pour it out.
Probably missed that.
So then I'm going through this and just kind of sweeping through, checking for, like I said, stones, rodent pellets. As an example, this is what I found in this sample. It's a whole bunch of rodent pellets. We got some stones in there. If there's over 2 rodent pellets in a sample, it'll make the sample go sample grade, which is not for human consumption. All right. This is also what Jeff broke down at the sieve. This is a 60 gram portion. I'm going through this for foreign material, like barley, rye. Since this is a wheat sample, that's considered foreign material. It shouldn't be in the wheat sample because they use barley for different stuff like beer. Weed seed is also stuff that can get into there. We'll pull that out. If it weighs up, then we mark it on the foreign material line. If it doesn't, then we don't have to put anything. So after I go through my 60 gram, I will break it down a couple more times to my damage picking portion, which is 15 grams. And these kernels I'll go through individually and pick out damage, sprout damage, frost damage, mold damage. And if there's insects in there, if I saw any insects, I would look for insect damage as well. Even if there's not, I still keep an eye out for it. This one has some sprout damage in it. This is a winter wheat sample, but I'm also looking to see if there's any spring wheat in there that isn't supposed to be. They like to keep the spring wheat and the winter wheat separate, so we also have to know the difference between the two. We train for that when we take our test, and even as we're sitting here, if we find one that's questionable, we'll pass it around to each inspector and kind of get a consensus of what we think. And we also have a really big library over there with different varieties of wheat samples. So if farmer calls us and says, no, that's actually all spring wheat, we'll ask for a variety, and then we can compare it to our library to make sure that, you know, it's actually what he says it is, and sometimes it is, and sometimes it isn't.
Once he's done analyzing, Lauren gives the sample a grade. This particular batch had 4 stones and 12 rodent pellets, making it sample grade, the lowest rating on the scale. Farmers strive for a U.S. #1 grade on a scale that goes up to 5.
So if this sample did not have any stones or rodent pellets, according to my test weight, I would look over here for winter wheat. Minimum limits for test weight is 56 for number 3, and I had a 57, so I'm above the minimum, so that would make this go a number 3 hard red winner.
Okay. Hard count, the technical term is DHV, dark, hard, and vitreous. And our normal 5-year average for hard counts in Montana is well over 90%. And that's really what Montana is known for, is spring wheat, high protein, vitreous, rich color.
Good grain.
Great grain, right? And that's what makes us distinct in our Asian market. This year, we had challenges during harvest because we had untimely rains. And those rain events essentially bleach out the kernel. So instead of being dark, hard, and vitreous, it's soft. So as a grain inspector, they're going to go through a spring wheat sample or a durum sample and determine the percentage of kernels that are hard versus those that are soft.
So for a spring wheat sample, we would go through our 15 gram portion like this. And if there's any questions whether it's hard or soft, we would take a razor blade and we would cut that kernel. Oh, if I can get it, and if you can see that white, it's like almost chalky spot in the center, that means it's soft. And so we would separate that out and we would give the farmer a percentage of what they have that is hard count compared to what they have that is soft count of wheat. And we will break down every sample basically the same for each commodity And that way each inspector will break it down the same, and that would be the same as the people in Kansas City, the people in Oregon that are federally licensed. That is our goal, is to provide non-biased quality inspection for each sample that comes across our desk. If you have good quality grain, we could get through a sample, once it hits our desk, in about 2 or 3 minutes.
Okay.
Because of the 5 days of rain last year, we had a lot of sprout damage, especially in barley. Barley was taking us each sample an average of half an hour to an hour for one sample, because we have to break down and open up each kernel for sprout damage in 30 grams, which is it's a massive amount for each kernel to do. A good day, each inspector could do 50 to 100 samples. That's just a guesstimation on if it's good quality grain. A bad day, maybe 20. And it's just all on the quality that comes across the desk.
In a typical year, the Grain Lab tests about 30,000 samples, mostly wheat and barley, followed by pea and lentil samples. And Remney adds that there are some not so well-known grains that make the state unique.
We have standards specifically for niche products that are grown only in Montana, like hulless waxy barley. That's a product that was developed in Montana, grown in Montana. It was developed about 30 years ago at MSU, and that product is now used on the Kashi bar.
One of the most critical steps performed at the State Grain Lab is the protein analysis.
Basically what this machine does is going to shine a light on the sample, and based on the reflectance pattern and the transmittance pattern of that light, it's going to determine the protein content. So on great spring wheat protein, our state average is usually around 14%. We see samples all the way up to 16%, and then can be as bad as 10 or 12%. So what this machine is going to do is it's going to take 10 subsamples of the little bit of grain that I poured in, average all that information, and predict a protein content. Protein is one of the most important factors to determine the value of the spring wheat and winter wheat crops that we raise. It's also critical in barley. Some years, based on the harvest, the value for high protein can be a tremendous benefit to producers. And that's really how we distinguish our commodities in the Asian market, is our high protein spring wheat that we raise. So this particular sample, we can see the results are going to be 11.27 or 11.3%.
After results are completed, they are entered into the lab's data system. Then producers, elevator managers, or whoever has interest in the sample can see the results on a secure website, usually within 48 hours of dropping off the sample.
We don't determine the value of the crop. All we do is we look at the quality of the samples. And if you ask one of our grain inspectors, what's the price of wheat this week? They don't even know. In fact, they don't even want to know. Okay. We want to keep the work that we do as abstract and as unbiased as possible.
Occasionally, producers will dispute the findings.
Say that they were sure that the protein was going to be, say, 11.5%, and we reported 11.3 on our grain certificate. So what can they do? Well, it's a very simple matter. They call us and say, I would like a retest on that sample.
So we keep the samples for 2 weeks. We keep them all libraried here. So if there's any rechecks, anything like that, we can pull it and rerun it.
Besides mechanical and interpretive analysis, another key test performed at the Montana State Grain Lab is one called falling numbers.
And this test was developed over 50 years ago, and it's a measure of sprout damage that occurs in wheat. So under normal conditions, producers are out in their field, they're combining their wheat, haul it to the bin, and everything is high and dry, and the grain is in perfect condition. Unfortunately, usually it's some point in Montana, in some place in Montana, that wheat is rained on during harvest. And those little kernels of wheat think that it's time to grow because they've gotten wet. And that's what this test is going to measure. Now, as a grain inspector, when you're on the inspection table, your job is to pick out that sprouted grain. But when you can actually see the sprout, the damage is already there and it's already severe. What this test is designed to do is pick up the damage early. So what does falling numbers measure? Well, falling numbers is an indirect measure of alpha amylase activity. And I realize there's a lot of jargon in there, but every living organism on the planet has alpha amylase. Alpha amylase is an enzyme that converts starch into sugar. So wheat stores energy as starch. During the sprouting process, the wheat releases alpha amylase and converts that starch into sugar, so the plant has energy to grow. So if we have untimely rain during harvest, the enzyme is released into the wheat, and we're trying to detect that enzyme with this test.
Before determining falling numbers, samples of wheat are ground, a job performed by Kari Schiller, currently a head tech at the lab who is working to become an inspector.
This is our grinding room. 2 grinders. We have a nice ventilation. The air system that comes in and out goes right to the outside. We take 250 grams of a sample and we grind it. We throw into the grinder. This is our feed process here, so it goes into here, comes out through the bottom into a cup as it grinds from the inside here. So this system turns in here, so as it goes through, it grinds, comes through here, grinds over here, and then you mix it up, stir it up, put it into one of our little bottling systems, and then after it's ground up, just like so, card, and then you send her through.
So what we're going to do is we're going to mix together 7 grams of flour that we've weighed out with 25 mils of distilled water and put that in our shaking machine. And we're essentially making a slurry of water, flour, and we're going to add that to our hot water bath. So essentially we're making a little glob of thick gravy. So if the wheat is sound and undamaged, that little blob of dough will remain stiff. If the wheat is damaged, the enzyme activity is present, that little blob of dough will be converted from starch into sugar, so it'll be very thin. And that's what this test measures, is the viscosity of that dough, or the thickness of that dough. So Joey's loading it into the machine. The machine is going to stir that sample and then run the test. So much of our wheat goes into the milling market in Asia, and those markets have a contract rate of 330 falling number points for all the spring wheat that we deliver, or 300 for the winter wheat. So the samples that we're looking for here, or the values that we're looking for here, we hope that they're going to be over that 330 mark. So really why we do this test is that during the sprouting process, you can think of it as a 3-step process. The first step is where that kernel is absorbing moisture from rainfall. The second step is where the kernel is releasing the enzyme into the kernel to convert the starch into sugar. And the third step is where the sprout is actually coming out. So as an inspector, you're looking at the third step of the process, where the falling number test, is looking at the second step of the process. So this is designed to detect the damage earlier than what the inspector can test. So if you are an end user of the flour, say you're making bread or cookies or pasta, the falling numbers is really important. If you try and make bread out of flour that has a really low falling numbers, it just doesn't perform very well. Perhaps you've gone to the store and you've bought the discount pasta, and you take it home and you cook it up, and it's stewy, or it's sticky and gooey in your cook pot. That could have been made from pasta with a really low falling number.
Rumney says in a normal year, the State Grain Lab runs about 15,000 falling numbers tests. He says the falling numbers test is important because of all the evaluations It is one of the least understood.
As a producer, most producers have a fairly good understanding of the grading process, what test weight means, what shrunken and broken means, what damage means, because you can see those things out of your combine. You can see damaged kernels or undamaged kernels. But falling numbers, most producers don't really have a good understanding of it. And if they deliver their grain to an elevator and all of a sudden their results show that they have poor falling numbers and they have a discount associated with those poor falling numbers, I really wanted to point out what the process was so it helped to understand why those discounts are coming to them.
As the Grain Lab provides analysis to producers, the facility itself is closely monitored.
So the federal government provides us oversight, monitoring for our processes, and also comes in and actually physically will do an audit with us. They'll go through our bookkeeping, our record keeping, our grain sales, all of our equipment, all of our procedures, our inspection processes, so that they're assured that we're giving accurate results, also that we're giving unbiased results, so we're not having any undue influence from outside entities that might affect our grades. So the work that Lauren was doing, we were showing grain inspection, and he was going through that sample. Essentially 1% of our samples are randomly selected each day. We bag up those samples and they're regraded in the federal lab. And we look at those results for quality control to make sure that the inspectors are consistent all day long, every day.
Rumney says that federal regulation further establishes the State Grain Lab as the premier analysis site in Montana.
One of the things that's interesting about our lab is that virtually all the work that we do here, these samples are brought to us by the choice of the producer. And the producers actually have a choice other than the State Grain Lab to have their grain analysis done. There's a private company in Great Falls that does grain inspection, but they do it unofficially. So indeed, we are a fee-for-service business to do a complete analysis of all the laboratory tests and a protein analysis. It's about $25 to do a test. So most of the revenue associated with the Grain Lab is the fees that we charge producers. We do get some revenue from the general fund to help support our base revenue. And also the Montana Wheat and Barley Committee provides funding for equipment here at the lab. The Montana Pulse Advisory Committee has also. So we have multiple income streams. Most of the revenue comes from the fee-for-service.
By the Grain Lab's nearly century-long presence in Great Falls, it's evident that Montana has a rich agricultural history, and the industry has a promising future, thanks to young Grain Lab workers like Lauren Almond, Kari Schiller, Tim Hall, and Joy Blystone.
Falling numbers is what I originally did here a previous harvest a couple years ago, and so I feel really at home in this room and push through samples like a crazy person, I guess. Just go and go and go. I just like to be a part of our industry. I think that what we do here is really good and it's good for the people.
We hope you've enjoyed this in-depth look at the Montana State Grain Lab. We'd like to thank Jeff Rumney and his staff for allowing us access into the facility to give you a better look at how some of the products grown in Montana that go into the food you eat are tested and analyzed. Thanks for watching this edition of Face the State. I'm Tim McGonigal.
You've been watching Face the State, a presentation of MTN, the Montana Television Network.